Okay, we have this system. Now, how do we solve the system? Well, we're going to add multiples equations to other equations and do similar things. As we did in class last time in quite a bit of detail. Now, what I've got here, I wrote down the wrong quiz because I got backwards on what we're covering here and what we're covering in the actual precalculus class. But that's going to pretty much be your quiz in precalculus. And some of you got it right, some of you weren't quite sure about it. Okay, anyhow. Okay, now I really urge you to follow the procedure that I do. Because, well, there's just a whole lot of good reasons why you want to do that. And you're going to see a lot of those reasons in pre-calculus and elsewhere. Okay. So I prefer to label these equations 1, 2, and 3. Now, nobody had any trouble eliminating a variable. I didn't really pay that much attention to who eliminated which variable. How many of you eliminated Y? How many of you chose to eliminate Z? That's the better choice because all these numbers are multiples of 3. So it's going to be pretty easy to eliminate Z. It wouldn't be terribly hard to eliminate Y, but we'd have to do 2/3 of this and 3/2 of this, or you know, 2 times this, 3 times this. So we wouldn't do that. If we have something that lines up nicely like this. So what we're going to do is we're going to try to eliminate Z from the first and second equation. Okay. How do we do that? We add equation 1 to 3 times equation 2. Okay. If we do 3 times this and add to this, Z is going to go away. And we wrote that down. Because you go back and look at this and there's a mistake, you'll forget what you did. If you're like me, you'll forget what you did. You know, if you're a little more attentive, you might not forget, but you can't rely on that. You could easily forget what you did here after you worked through the whole problem and found that you didn't get the right solution. What are you going to do? You're going to go back and check your steps. If you don't know what step you did here, you're going to be at a disadvantage. Okay, it's going to be harder to debug your solution. So document what you're doing. Okay, so now over here I can do that. And I'm even going to label that. Okay, and I'm going to move the board over a little bit so we can see what I'm writing. Okay, 1 plus 3 times 2. That would be 2x minus 3y plus 9z equals 5. This is equation 1. And 3 times equation 2. I didn't leave myself room to write all this, but there it is. Well, then we've got to multiply 3 by both sides. That's what we mean by 3 times the equation 2. It's a shorthand for multiply both sides by 3. And I think you understand that. So we're going to get 9x plus 27y minus 9z equals 54. And so I think that's probably right. So we're going to add those two. And we're going to get 11x plus 24y equals 49. Now you might have chosen to do it differently. You might not have gotten this equation if you did something a little bit different than what I did. And just double checking, first equation is copied down right, because we don't want to make a mistake at this point. And I don't want to make a mistake right now at this point, so I'm being extra careful because I'm prone to, you know, talking, looking here and there, messing things up. Okay, so 9, 27, and minus 9 and 54. I think it's all right. Okay, so equation 1 plus 3 times equation 2 gives me 11x plus 24y equals 54. So now I've got these two equations combined to give me an equation that doesn't have z in it. We want to get another equation that doesn't have z in it. Okay, well, that's not difficult. We could eliminate z between the first equation and the third, but the 6 doesn't go into 9, so we'd have to do multiplication by 2 and then a multiplication by 3 and stuff. So we'll keep it as simple as we can. We can eliminate from these two just by doing equation 3 plus 3 times equation 2. 2 times equation 2, sorry. Catch that 3 out of the corner of my eye. I'm prone to write it down. You're probably prone to different kinds of errors, okay? Just the way my visual field works, I've got to be careful about stuff like that. Okay. So we'll do that over here. We're going to do equation 3 plus 2 times equation 2. Okay, well, equation 3 is 5x plus 2y plus 6z equals 15. And then 2 times equation 2 is 6x plus 18y minus 6z equals 36. Okay, so everything's multiplied by 2. 2 times 3 is 6. 2 times 9 is 18. 2 times -3 is -6. And 2 times 18 is 36. So if I've done my arithmetic correctly, I get another good equation. Well, that's going to be convenient. I've got 11x there. Okay. Plus 20y equals 51. So I can write that equation. 11x plus 20y equals 51. Okay. Now, should be obvious, but tell me, this for x. Yeah, how about, no, I don't want to go to the right line. This for x, this for y, right? How many want us to eliminate x? You look at these equations, which one is easier to eliminate, x or y? Well, I've got 11x and 11x, right? That should be really easy to eliminate. I could subtract this equation from this one, okay? Now, we haven't done subtraction because usually we choose to multiply by a number that gives us a positive in one equation and a negative in the other. And when we're multiplying by different numbers, we always want to do that because addition is easier to keep track of than subtraction. You have fewer negative signs to worry about. And negative signs are one of the hugest sources of error, okay, in all of algebra. And I'm going to risk it. I'm going to try to do equation 1 minus equation 2. 11x minus 11x gives us 0. And then it's going to be plus because 24y minus 20y gives us 4y. And then 54 minus 51 gives us 3. And that's really screwed up. I probably made an error either in setting up the equations or in one of these steps. So I'm going to pause the video for a minute while I double check my original equations. Okay, now I did make a mistake, and I'm glad I wrote everything out here. And I didn't just pretend to make a mistake. I allow myself a certain number of mistakes because you get to see what happens when you make a mistake. Okay? So 5 and 54 is 59. Yeah, it's going to work. So this should have been, oh, this is 54. No, this should be 59. And I think I copied my numbers down wrong too. No, I guess I copied them down right. Okay. Anyhow, that's 59. Now it's 51. Now when I subtract 51 from 59, I don't get 3, I get it. So you see how smart I was in setting up my mistakes. I didn't have to do a lot of work to change a 3 to an 8. Okay, well, not really. I didn't plan that. I don't have to plan it. It happens by itself. Okay, so we have, I think a little better than I. Try to make it better than I. Just that was an awful lot more. Round it off a little bit. Okay, so we come down here and of course we get y equals 2. All right. Well, we continue the solution. Yeah, continue that on fresh board. So I'm going to move this scratching over here. Now remember, pay attention. I want this all to be aligned in a column. I want these equations to line up, and really, I want the equal signs to line up. I want the x's to line up. I want the y's to line up, and I want the z's to line up. Okay? I want that all lined up, and you want that all lined up for what we're going to do after we solve this. Okay? If you got them lined up, then the next step, and or actually kind of the last thing we're covering in this course is I'd like to finish up the content of this course a bit early, so we have plenty of time to review and answer questions and see what you still need to support your precalculus course. Okay, so okay, we have this. Okay, now we continue. We take this value of y and we substitute it in one of the equations. I'll take this value of y and I'll substitute it in one of these equations, not into this equation. Okay, so this is inserted in here. I don't know which y do you want to use, this one or this one? Up or down? Down, down. Oh man, that was quick. That was unanimous. Okay, so we get that, and we bring that over to here. Okay, so we're going to get 11x plus 20 times 2 equals 51. And actually, the idea of keeping things aligned, if I wrote this directly below this, hopefully this and this and this would align with this column, and this column. You want to start looking at columns. You're going to find out why shortly. Okay. Well, then we solve and we get x equals 1. Let's keep it aligned. X equals 1. 3 dots there to indicate, yeah, we do the steps, but we know those steps. Everybody's been good with linear equations since the first day of class. Okay. Now we have x equals 1. Well, we're going to plug that in along with the y equals 2. Then I'll write out well, no. Okay. Now we're going to plug y equals 2 into one of the first 3 equations, one of the original 3, along with x equals 1. Because we plug in y and x here, we're going to be able to solve for z. Okay, well, got to find a way to draw an arrow here. Move things over just a little so we can see everything. Okay. So we also take this and plug it in for Y here. And we take this X and we bring it over here. Yeah, and plug it in for X. And from that, we get the equation 2 times 1 minus 3 times 2 plus 9z equals 5. But just check out, make sure we solve it. I'll actually solve it. I'll do it in my head. You can do it easily. We're going to get -4 here. So I'm going to add 4 to both sides and I'll get 9z equals 9. Z equals 1. Oh, solution is, I'm going to write it as an ordered triple because we could actually plot this as a point in X, Y, Z space, a 3-dimensional space. Okay, we're not going to do that, of course. But it's worth saying. Okay. And the reason it's worth seeing this in 3-dimensional space is it turns out that each of these equations gives you a plane in 3-dimensional space. Now, 2 planes cut each other along a straight line. A third plane will cut that straight line in 1 point, and that's the point. Okay? So some of you might have linear algebra course, polar variable calculus course in your future. It'd be worth kind of thinking about that. Most people who don't have those in their future don't need to really think about it. Oh, it's kind of neat to think about. Okay, so anyhow, here's your solution. Check. Equation 2 becomes 3 times 1 plus 9 times 2 minus 3 times 1 equals 18. So 3 plus 18 minus 3 equals 18. Well, 3 minus 3 is 0. Put a check mark next to that. That checked. Okay, just to be safe. Now, if you check in equation 2, it's very unlikely that your check is going to work, but you made a mistake. Now, you don't want to plug these back into equation 1 because you used equation 1 to get this. So naturally, if you solve this correctly, it's going to check out in equation 1. Okay, so you don't use equation 1 to check it. If you use equation 1 to substitute, you could have used equation 2 or 3 to get the same result. Okay, but you've already used that equation to get your solution, and you've used that equation by itself to get your solution. So you don't want to use that equation as part of your check, although that would be fine. But make sure you check in something else, and preferably check in all 3 equations. Equation 3 becomes, well, we'll just substitute 1, 2, 1 here. We get 5 times 1 plus 2 times 2 plus 6 times 1 equals 15. Well, if we multiply that out, we get 5 plus 4 plus 11 equals 15. And we add these numbers up. On this side, we get 15. And on this side, we get 15. We can put a check mark next to that one. And now it's extremely unlikely that you messed up solving this equation, but you could plug these numbers in. 1 here gives you 2, 2 here gives you -6, 1 here gives you 9. 2 and -6 is -4, and 9 does give you 5. Didn't write that out. But if you're on a test and you want to be absolutely sure you get this, take the time to do that. Okay? Now, if I say check on a test, I'll be okay if you just check one of the other equations. Don't check the solution in the first equation. If you did this right, it automatically works. Check it in the second or third equation. Okay? And understand that really you ought to check it in all three. But on a test, I don't expect necessarily take time to do that. If I say to check it, at least check it in one of the equations, okay? Okay. Now we're going to expand this whole idea. Going to take the same system. Well, before we do that, you're going to learn to multiply a row by a column. Now, to multiply a row by a column is really, really easy. Okay, I'm going to designate a row with a pair of brackets and 3 numbers. Okay, this is a row. A column is going to be 3 numbers, but they're going to make a column, not a row. Okay. When I multiply this, what I get is this. Do you see the pattern? Why did I multiply 2 times 1? Where is 2 and where is 1? Okay. Where's 2 in this row and where's 1 in this column? Well, hold up a finger or 2 or 3. Okay. Is 2 the first, second, or third number in the row? First number, right? Is 1 the first number, second number, or third number in the column? So I multiplied the first number in the row by the first number in the column, right? Okay. Now, what about 4? Where did it come from? Is it the first, second, or third number? Here. Oh, it's a second. Everybody sees that. And is the 2 the first, second, or third number in the column? Okay, it's a second. So I multiply the second number by the second number, right? What about -2? Well, -2 is the third number in the row. You know that. You've already figured that out. And -3 is the third number in the column. Okay? So first number times first number, second number times second number, third number times third number. Okay? If you don't have a third number over here and you do have a third number over here, you can't do the multiplication. You got to have exactly the same number of numbers in this thing as you do in this thing. Otherwise, you can't match them up, and it makes no sense to multiply them. Okay? Now, believe it or not, all this gets fairly quickly into transformations of space. Okay? So it's got a huge, they're 2 huge courses that most undergraduate mathematics is based on. That's linear algebra, which this is leading to, and this calculus sequence, which pretty much everything else in precalculus is leading to, with an emphasis on rates of change. Okay, because that's connection with calculus. All right, just a little foreshadowing there. Now back to this. Well, tell me, what does this equal? Write it out. Okay, just write out the solution, write out the answer. And circle your answer so I can see it. Okay, so everybody got 16. I think that's right. I haven't added it up yet, but I think I'll be able to do that in a minute. Okay. And everybody, interestingly, put square box, or not everybody, 2 out of 3 put a square box around instead of a circle. And that's fine. You know, just something that makes it prominent so I can see it. But more than half the class didn't quite write it correctly because they didn't include the brackets. Okay, now I'm repeating what I said a minute ago, but I didn't have the quarter on. And the brackets are important when you're trying to keep track of the type of thing that you're getting. Okay, so this is a type of thing that has brackets around it because when you multiply a row by a column, you do end up with brackets. You'll see more about that in a minute, and you probably have a better appreciation for it. I'm trusting you all on that 16 because I haven't calculated it yet. Now I'm going to calculate it. I got 2 here, and I've got 8 here. That adds up to 10, and I've got 6 here, and that adds up to 16. Well, unsurprisingly, you got it right. Everybody agreed. So who am I to question? But I'm going to trust but verify. Okay. Okay, so there we have it. Okay, that was easy, wasn't it? It was. So say yes. Yes, it was easy. Okay, very good. Okay, thank you. I need that confirmation. You know, a little insecure. Okay. Now, how about if you do this? Now you've got 2 rows. Well, I'll give you a hint. You're going to multiply the first row by the column, and you're going to multiply the second row by the column. Okay? Now, you might not be sure of what to do with them, but get the numbers and take your best guess as to how you want to represent those numbers. And that I'll show you. You're going to get 2 different numbers, one for each row. Okay. Everybody pretty much did the right thing. Okay. But only one person used the format. It's going to work as we go forward here, but nobody knows where we're going unless you've seen this before. Okay. So what we get here's the way one person wrote it out. Actually, I'm probably going to need more space. It's foolish that last bracket in there until I've written it out. Okay. So first row times a column, not here. Which makes sense because that's the result of the first row. Okay. Result of the second row. Right here. And that's mathematically totally correct. Again, for reasons that if you don't happen to have that direct pipeline to the secrets of the universe, you wouldn't have anticipated, okay? Okay. You'll see in a minute why it's gotta be this way. Okay, well, we add these up, we get 2 and 8 and -3 gives us 4. I think everybody got the right numbers. And 1 and 6 is 7, and this makes 15, makes 22. That's the right way to do it. Now, it wasn't wrong if you did it another way today, okay? I just said, do whatever makes sense, okay? Now, why does this make sense? Well, we're gonna do another one. I'm just gonna see how people can do with it. Okay. Yeah. One more thing. Sorry to have to do all that engineering in your time. There it is. Okay, so now we want to do this one. We want to do. I'll make it easy on you. I'll use the same numbers that I did here. And I'll use the same numbers I did there. But I'm adding a second column. So what do you think we ought to do with that? Okay, just looking at this, and no criticism of what anybody did, but we're going to want to use all these numbers. And we're going to want to multiply rows by columns. Well, that means we're going to have to multiply each of these rows by each of these columns. Okay. Now, some people, I think, maybe did the first row times the first column, and then the second row times the second column. That would also make sense at this point, but that's not what we do. Again, for reasons that you'll appreciate in a little while. Okay, so what we want to do. Relieve myself, hopefully enough room here. But and then okay, so it's going to start this way, and you're going to get just the same numbers you got before. You're going to get this column, okay? Because we multiplied both rows by this column, okay? And what do you think we're going to do next? We're going to multiply both rows by this column, okay? Now, where are you going to put that? Okay, well, the one person that did the whole thing put it down below here and made this. It got 2 more rows, okay? That was perfectly sensible. It was actually a good idea, and you know, it got all the calculations done, and I think they were all done correctly, although I didn't check. But what we're going to do is 1 times 2 plus 3 times -1 plus 5 times 4. Whoops. A little over. Okay. And then we're gonna do the second row. Oh, heck. Forget what I just did. That's what goes in the second row. Wouldn't make sense to put it in the first row because it's coming from the second row. Okay, it comes from the second row. We'll go down here. Let's do the first row first. We've got 2 times 2 plus 4 times -1 plus -2 times 4. Maybe a little hard to see that, but it's the first row multiplied by the second column. And then the second row multiplied by the second column gives you 1 times 2 plus 3 times -1 plus 5 times 4, just what I wrote before. Well, we can calculate these numbers. I think I'm getting 4 and -4, and then I'm going to get -8. And down here, I'm going to get 2 and -3, which is -1, and 9, which is 8. And there it is. Now, the thing that makes sense about this is this is the first row times the first column. This is the first row times the second column. What row is the first row times the first column in? It's in the first row, and it's in the first column, right? First row times second column is in the first row in the second column. Okay? And then second row times the first column goes in the second row here and the first column. Okay? And the first row times the second column goes in the second row and the second column. Okay? That makes sense? That's matrix multiplication. It's an example of matrix multiplication. And it's something that's going to be in precalculus final. And supposed to be in all precalculus courses, but with the confusion of the official disaster we had back in early October, and a couple of other disruptions. Not everybody might get to it, but it's something to do in the course. Okay. So the pattern could continue. Would it hurt anything if I added a third row here? What would happen if I added a third row? Well, I'd multiply the third row by the first column, then I'd create a third row down here. I've got to have as many rows here as I have up here. And I think you see that by the pattern. Okay. And I've got to have as many numbers in each column as I have numbers in the row. And then I'm going to have as many columns down here as I've got columns over here, because everything has to go in the row and the column it came from. Okay? I'm going to make that statement. Every row times column result of the, I'll say product, because we're multiplying 2 matrices. Now, I just used the word matrix. I've used it a couple of times, but I just wrote it out, so I better define what I mean. It just means an array of rows and columns. Okay? If you got 2 random matrices, you can tell pretty quickly if they can multiply. The length of a row The first one has to equal the length of the column of the second one. Okay? Another thing we don't do is we don't do columns times rows. We do just rows times columns. Now you're going to see notation probably in your text that confuses all this. Well, that notation is important because it's a more rigorous definition of what you're doing than just waving my hands and saying the row times column thing goes into that row and that column. That's not very specific, but everybody understands what I'm talking about right now. So that's what it is. Don't let the notation confuse you, but try to understand the notation. But when you do the calculations, you don't have to think about all that notation. Just think of the picture. Think of what you just learned. I'll give you one more. See how we're doing time. We're doing well. That's what we can matter. Okay. Okay, so see if you can use the principles that we've used so far. These matrices have different shape than the others. Make sure you can always multiply the rows by the columns, and then you're going to multiply every row by every column. Okay, every row of the first matrix by every column of the second, and you're going to figure out where to put it within a set of brackets. If you make a mistake, that's okay. You're still learning, you're still thinking. We'll correct it. Okay, time's getting short. You're still working, but everybody's doing something that makes sense. But still challenging to figure out, this is what we've done so far, where all the results go. Okay. So, without writing out too much, you know that 2, 4 multiplied by 2, 1 gives you 8, right? Everybody got 8, multiplying the first row by the first column. So we're going to put 8 here. If you multiply the first row by the second column, you're going to get 2 and negative 8, which is negative 6, right? So what's the rule? It comes from the first row in the first column. It goes into the first row and the first column. Okay? So first row, first column, first row, first row, first column. First row, second column, first row, second column. Okay, second row times the first column. 3, 1 times 2, 1 gives you 7, right? Everybody gets 7 multiplying this by this. Okay. And if you multiply the 3, 1 times the 1, negative 2, you get 3 and negative 2, which is 1. Goes in the second row, second column. Okay. So first row, first column goes in first row. Sorry, second row, first column goes in second row, first column. Second row, second column goes in second row, second column. Okay. Well, we've got a third row. Well, we're going to have to have a third row down here. We're going to have a row down here for every row up here. So we're going to get what? Negative 2 times 2 is negative 4, and 3 times 1 is 3. We get negative 1. And if I'm doing this right, we get negative 2 and negative 6, which is negative 10. Okay. Now I've done all 3 rows times the first 2 columns. Now I need to do all 3 rows by the rest of the columns, right? So we start first row times the third column. That comes out 8 and 20, 28. Okay. Everybody do that one? I mean, I didn't give you a whole lot of time. Everybody's got at least 4 rows and columns multiplied. Okay. This is negative 20, or this is 28. That's the first row times the third column. It's got to go in the first row and the third column. Okay. In the first row times the fourth column, 2 times 6 is 12, 4 times 3 is 12. You add that, you get 24. And then this row times this column, that's going to give you 3 and 2 is 5, I think. Check my arithmetic. Oh, well, no, there's a negative in there. No, okay. I'm looking at the wrong place. Okay, that gives you 12 and 5, which is 17. And this one gives us 18 and 3, which is 21. This one gives us, okay, third row times third column has to go in the third row, third column. We have a negative 8 and a 15, which is which is 7. Okay. And then third row, fourth column gives us negative 12 and 9, which is negative 3. Now, big question mark whether I did all the arithmetic correct. But do we understand that you could do this with any two matrices as long as the columns here are just as long as the rows, so we can match up all the numbers? If I had a third row down here, I wouldn't be able to multiply it because I wouldn't have a number here to match up with the third one. Okay. One last word since we got this stuff on here. Let's write it down. Take a look at this so you get a chance. I multiply the first row by the first column. I get 11 times x plus 24 times y. I multiply the second row by the column, I get 11x plus 20y. Those are two equations we got. That's the left-hand side of two equations that we got in reducing the matrix. And this then has to equal 59, 51. These can only be equal if the first row equals the first row and the second row equals the second row. Well, if you write that out, you get these two equations. Okay, so you can represent those two equations by a matrix. If you multiply both sides of this equation by the inverse matrix, it's going to cancel out this matrix and you're going to get what x and y are. Okay, and that's a hugely big deal, but we'll maybe talk about that a little more, maybe not, but for the edification of anybody who's going to go into a mathematically intensive field, we're seeing that right now.